So, number one, which of the following is an ionic compound? What does an ionic compound have? What does it look like? You may recall I said something like we always ask ourselves a question. What's the question that we ask ourselves? Oh, Rachel, you were the one that came up with it in class that one time. Is this ionic or covalent? How do I recognize by glancing at a compound what it is? An ionic is a metal and then a non-metal. Which ones are the metals? The left side of your periodic table. And the one that you have on the provincial is nice and color-coded, similar to mine back behind you on the wall. It's not all black and white. Which ones are the non-metals? The right side of the periodic table. So which of these is an ionic compound? Now, if I'm answering this on the provincial, I go process of elimination. First of all, A is not a compound. It's one atom. It's an F2 atom. You may recall we gave you this acronym here, Mr. Hofbrinkel, to help you remember. That looks like an I, Mr. Dueck. Let's do this. Now you can tell it's an L. To remember which ones are diatomic. These are atoms. If they're by themselves, they're never by themselves. They always pair up with each other. But a compound has to have more than one element in it. So F2, no. What about CH4? This is a different type of a compound. How would we classify that one there? It's another, sorry? Polyatomic? Nope. This is an organic compound. What was an organic? It had carbon and hydrogen and sometimes oxygen. Okay? What about C, this next one here? Well, I'm seeing this. That's a polyatomic ion because it's got a charge. This is a polyatomic ion. This is on the back of your pink sheet on the provincial exam. That page is a little further on. I can't remember where it is, but you have that same page there somewhere. Metal, non-metal, or polyatomic ion. D. D is an ionic compound. How do you name ionic compounds? This was the IDE rule. We'll talk about that when we get closer as well. Use the following board diagram to answer questions 2 and 3. What of the following is represented by the diagram? First of all, you can figure out what element it is by that right there, because the number of protons, what else does that tell you? Atomic number. What's atomic number 18? Argon? Okay, so it's argon. Now, argon, how many electrons does it have? Well, if it's not an ion, it also has 18 electrons, same as the number of protons. It's got a full valence shell. Why does it have a full valence shell? Because on the right side of the periodic table. Does this have a full valence shell? You may recall we had this, the 2, 8, 8, and then it got yucky 18 rule. This was, in the first layer you have 2 electrons, then 8 electrons, then 8 electrons, then 18. Then it goes kind of haywire, Alex, and we don't get too fussy after that. That allowed us to figure out whether it was an atom or an ion. This is going to be an argon atom. What if they had given you, I'll give you a different question. What if instead of an 18, what if there had been 16 there? Sulfur? Sulfur, but is it a sulfur atom or a sulfur ion? Because it has a full valence shell, it's gained those 2 extra electrons, it would be a sulfur ion. You would write it as, remember the square brackets and the 2 negative, that told you that it was an ion. So they can muck around with that. But this is argon, it's an atom. Let's keep going. How many valence electrons are there in this diagram? What does valence mean? Outer shell. How many are there in the outer shell? Okay. 8. They didn't ask me, but I'll write it here since there's room. What would the Lewis diagram look like? These were much nicer. You put the symbol, and then all you drew was what the valence shell looked like. So what would the Lewis diagram for sulfur look like? Sulfur is S. How many electrons does sulfur have in its valence shell? 8 or 6? If it's an atom, it has 1, 2, 3, 4, pair, pair. There's a sulfur atom, Lewis diagram. What if it's an ion? If it's an ion, Courtney, then it's gained a couple of extra electrons, and to show that we did that on purpose, we would say, draw the square brackets and put the charge to show whoever was looking at this diagram, hey, we didn't muck this up, we knew what we were talking about. That's the Lewis diagram for a sulfur ion. That's the Lewis diagram for a sulfur atom. Okay. Ammonia, oh, now we're into pH. So right away I'm finding my pH scale. You know what? Let me pause. So pH, the nice thing I like about the provincial exam version is you can see on the color portions, it's actually the color that it's supposed to be, which helps. So this question here says ammonia has a pH of 11. Which of the following is the correct color of each indicator when a small amount is tested? So a pH of 11 would be right here. And what are the colors that they gave me? Methyl orange. Methyl orange. What color would methyl orange be for a pH of 11? Yellow. Now, it's a multiple choice provincial. Joseph, get in the habit right away of crossing off answers that you know are wrong, because just by doing that, I've now turned the rest of this into a true-false question. I can guess with a 50-50 chance of getting right. Right? In fact, I think I can probably figure this out from bromothymol blue. It says green or blue. So bromothymol blue is right here. I think it's probably blue. Where would it be green? Probably right near the middle, because green and yellow and blue is kind of a greeny, so somewhere around neutral. I'll double check. What was the other one? Indigo carmine. Indigo carmine might be turning yellow, might be barely blue still. It's really, really close. You know what? Oh, blue, you know what? I think it's that one there. Is that right? D? That makes sense? Okay. Little pH. How many atoms of each of the following elements are indicated by the formula for what? Okay, if they had given me the formula, this would be a heck of a lot easier. Did they give me the formula? I've got to crisscross. I've got to write the formula. Ammonium, that's a polyatomic ion. It's a positive one. Ammonium is NH4 plus, I think. Am I right? I'm going from memory. And sulfite, I have no idea. I know it's not sulfide. If it was sulfide, it would just be a sulfur ion, but it's sulfite. Julia, what's the formula for sulfite?
Sulfite, SO3.
SO3, and its charge?
-2.
-2. So when I crisscross, the formula is going to be NH4 in brackets. It looks like I need 2 of them because the 2 ends up down there. And SO3, how many SO3s do I need when I crisscross? How many SO3s? What number goes there? 1. So do I need to put the 1 there?
No.
Do I need to put the brackets there? No. Okay, now, how many are there of each element? Okay, how many nitrogens are there in this mess here? 2 or 4 or 8? Because what number is sitting right there? It's invisible. So I would say no, it's C or D right now. You know what? I think I just need to do the hydrogens and I can quit. I don't need to do the rest. How many hydrogens are there? 8. C is wrong. What must the right answer be?
8.
Why would I waste my time going further? Yes, am I wrong?
Still not right, though. It's the right answer, but there's 3 options, not 4.
Is sulfite SO3 or SO4? Is SO3? So there's a typo on this test, I think. I don't know. Thank you. Thanks for pointing that out. I haven't used this before, and I haven't proofread it. It's not like we haven't found mistakes in the workbook and in the resources before, right? I've given out many a candy. Number 6, I guarantee they're going to ask on your test, on the provincial, and on your mock. Why? First of all, how would you read this to me? What is PbS2? First of all, even before that, what question do I ask whenever they give me a formula? Is it what or what? Okay, I always ask ionic or covalent, Because if it's covalent, then I'm going to be using the di, mono, tri, tetra, that stuff. If this was covalent, it would be lead disulfide. It's not covalent. How do I know? Metal. Non-metal. It's ionic. And lead is particularly yucky. If you find it on the periodic table, can you tell me why lead is particularly yucky? It's multivalent, which means I'm going to have to, when I write it out, use Roman numerals. In other words, wrong. I know it's not covalent. B is written as a covalent, and multivalent has Roman numerals. It can't be A. I need to figure out the charge. You know what? Because this is multiple choice, I would probably look at both of the answers that they gave me and ask which one of these works. So the first one that they gave me says maybe lead had a charge of 2. That's why it says lead in Roman numerals 2. What's the charge on sulfur? 2 negative. If I crisscrossed, what would I end up with? If I did that and that, what would I end up with? Courtney, you're right. Just this. Is that the formula that they gave me in the original question? No. So this here is wrong. I'll just put a line through it, but I'll keep it on here so you can see my thinking. Let's check the other one. Oh yeah, now I'm feeling good because the other option is Pb4 plus, and you said sulfur is 2 negative, and when I crisscross, I'll get a 4 there and a 2 there. But remember, it wasn't just crisscross, it was crisscross and what? Reduce. When I reduce, becomes a 1, becomes a 2. You know what? That is the formula for lead 4 sulfide. They're, I guarantee, going to give you a on Wednesday and on the provincial, Matt, they're going to give you a multivalent ionic. They're either going to give you the formula and say write the name, or they might give you the name and say write the formula. But if they give you the name, it's so much easier, because if they give you the name, they've given you the charge. You don't have to even think about it. They'll almost certainly give you this and go this way. Okay? Which of the following is an inorganic compound? Okay. What does an organic compound have? Carbon, and then usually hydrogen, and often oxygen. So which of these is inorganic, even though it's got carbon? Right? Because that one there is, carbon is acting like a non-metal, not like a metal. Which of these is an alcohol? I gave you a stupid way to remember that. Which of these, I don't know if you saw this one, is an It had to have those 3 in it. The word alcohol has a C, an O, and an H in the middle. An alcohol compound has to have a carbon, an oxygen, and a hydrogen, which is that one there. What about this one, Mr. Dueck? That's got a C and that one's on your formula sheet. Go check your polyatomic ions, check your acids. This is chaku, which is what? Vinegar, right? I think, what's it called? No, it has a name. Back on the polyatomic page where the acids are. Back of the pink sheet.
Acetic acid.
Acetic acid.
So that's an acid, not organic. Okay? Sorry, that's an acid, not an alcohol. It is organic, but it's not an alcohol. What type of this is very, very tough. What type of reaction would you expect when potassium carbonate reacts with magnesium nitrate? Single replacement, double replacement? Okay, at least they've given me the cues. Sorry. A is the inorganic one. C is I asked which of these was the alcohol, and so I circled that one, but yeah, you're right. So remember, we had types of reactions. Single replacement. A single replacement looked like this. Became Cb plus A. Or we had double replacements. Swap partners. Or we had acid-base neutralization. How can you recognize something is an acid? What did it start with? H. How can you recognize something is a base? What did it end with? OH. So what makes a neutralization? We had acid plus base, and that always gave a salt plus water. What did an acid start with? Max? H. What did a base end with? Can you see where the H2O comes from? Can you see where the HOH comes from in the right-hand side of the neutralization equation? And what that means is, Julie, if you realize that that and that give me the water, then whatever's on the right of the H, a non-metal, will combine with whatever's in front of the base, a metal, and that's your salt. Just crisscross properly. Okay? And then balance. Now, they're not going to give you a huge, if they do give you a huge nasty equation to balance, save it for last. Don't spend 20 minutes on it. It's 1 mark. Don't take it seriously. Really? Yeah. Now, then we had combustion. Combustion was a hydrocarbon. Can you suggest or can you tell me what 2 elements would be in a hydrocarbon? So maybe something like CH4 or CH6 or something like that, or C2H, okay? Plus oxygen, because you need oxygen to burn. Who remembers what the products were for that? CO2 and H2O. When something burns, you get carbon dioxide, a greenhouse gas, which is why burning fossil fuels is a problem, and water. And you can you also see where the CO2 can come from and the H2O can come from? They're all hidden in here. These ones were often, Tyra, really yucky to balance. Now, this one here. So we had single replacement, double replacement, acid-base neutralization, combustion. I'm forgetting a couple, but we can look those up. What can you expect when potassium carbonate reacts with magnesium nitrate? Well, here's what I notice. Julia, open your eyes, kiddo. AB, magnesium nitrate. I think this is an AB plus CD. I don't even think, Andrea, I need to write out this actual formula. I think I can spot the pattern. What kind of a pattern is that one there? Single replacement, double replacement, neutralization, or combustion? First of all, do you see, is it combustion? First, is it single replacement? No, because that was 3 things, right? A pair plus a singleton. I got 2 pairs. I'm thinking double replacement. Is it a combustion? No, Mr. Dueck, there's no hydrocarbon or oxygen. It ain't that. Is it a neutralization? I don't think these are acids or bases, because acids ended in an ick or an like hydrochloric acid or something like that. It ain't that. So you know what? As a process of elimination, it's going to be that. When a flame is brought near a lump of coal, the coal slowly begins to burn. When the same flame is placed in the path of falling coal dust, an explosion occurs. What's the factor that causes the second reaction to have a faster rate of reaction? Yeah. Nice. Yep. What questions do they love to throw like this on the provincial? Kindling is a great example of why logs are tough to burn. Kindling is easy to burn. Surface area. Okay, or heating something up, temperature to have the molecules bump into each other at a faster energy rate. You get more collisions per second. You don't increase the number of molecules. Increasing the concentration increases the actual number of molecules, which makes it more likely that you'll get the chemical reaction because they're more. Remember, I showed you the video about how increasing reaction rates was like 2 high school seniors trying to get a date where they bumped into each other in the hallway. We talked about all the different ways that was sort of the same. Someone asked a question here? So it's saying, what can increase react? We had 4 things, like 5 things. 4 things that can increase reaction rate. Temperature, the presence of a catalyst, concentration, or surface area. here, this explosion that occurs is the same reaction rate. It's coal burning, but it burns so fast, it's an explosion. Why does it burn so fast and have it end up being an explosion? Because it's coal dust. There's a much higher surface area because the pieces are smaller. Okay? If not, I'll go over that later. By the way, also, if there's questions you're like, I'm not sure, make a mental note, and I should have time at the end of this to go into more detail, but I want to get through every question here too. What element is formed during the alpha decay? You know what? Underline the word alpha decay, because an alpha decay was for that and that. Right? So uranium-235, that's going to be U-235. Can someone, what's the atomic number of uranium? I need the number that goes down at the bottom here. I don't want the answer yet. I want to walk them through how to get it, but thank you. What's uranium? 92? Okay. If it decays and one of the products is a mystery, but I get an alpha decay, remember the trick for these was these had to add together? These had to equal each other? Tyra, what do I have right here as a number? What do I have right here? So this must be 231. And what do I have right here, Tyra? What do I have right here? This must be 90, and this tells me the element. What's element number 90? Thorium, which is symbol TH or TR? TH. Now, this is too easy, this question. What they would have on the provincial would be thorium-231, but they might also have like a thorium-235 or another thorium just to distract you where you got the masses wrong. But those were the radioactive equations. People did pretty good on the radiation test. Turn the page. All right. On your provincial, there's not going to be a matching section, but this is good terminology. Alex, for matching, I find it easier to start with the definition side and go find the word. So what do we call a substance that increases the reaction rate without being used up? Okay, that's a catalyst. So I'm going to go cross out A, and I'm going to put A next to catalyst. What's a nuclear reaction that involves the splitting of nuclei? So we had two nuclear reactions. We had fission and fusion. One of these was combining nuclei, small atoms into big atoms. One of these was splitting nuclei, big atoms into small atoms. Which one was splitting? Fission. Fission. Oh, I don't see it. Do you see fission there? I'm going to cross out B. I don't think it's being used. Formed in the reaction of an acid and a base. Salt plus water. Produces hydrogen ions in water. Now, what actually produces hydrogen ions in water is an acid. When you pour an acid, or when you dilute, or when you put an acid in water, all those H's in the front become very aggressive, and they want to get electrons, and they're aggressive enough that they'll yank electrons and burn things while they do so. So, do you see acid there anywhere? I don't think we use D. Come back to that. The kind of chemical bond in which electrons are shared. And I always remember another word for sharing from Sesame Street is what? Cooperation. What? Sorry, what? Cooperation. Sorry, what? Cooperation. Which bond has sharing? Covalent. Cooperation. Covalent. That's going to be E. The time it takes half the sample of a radioactive substance to decay. Half-life. F. Number 17 is F. The main type of nuclear reaction that occurs in the sun. Fusion. We can also do it on the Earth. We're getting closer. Atoms of the same element that differ in the number of neutrons. This is one that they love to ask because this is actually Science 10 brand new stuff. Okay, that's what an isotope is. So, for example, there's potassium. What's the atomic mass of potassium?
39.
What's its atomic number?
19.
So there's potassium 39. There's potassium 40, still has 19 protons, but it's got an extra neutron. And there's potassium 41. These two are radioactive. There's some of them in every banana that you eat, for example. All of you have eaten some radioactive potassium. No biggie. It's not that big an issue. But an isotope is same number of protons, because the protons, Tyra, can't change. If it changes the number of protons, it's a whole new atom. It's not an isotope. An isotope is got the same number of protons, but same atom, different number of neutrons, different mass. Okay? So isotopes, which was H, also Springfield's baseball team. Type of chemical reaction that has one product. Synthesis, 20. She sells synthesis by the seashore. She sells synthesis. I have trouble with that word. What produces an acidic solution when dissolved in water? Oh, this was that. Yeah, that's obscure. Non-metal oxide, I think. Okay. Oh, I missed one, did I? Produces hydroxide. Hydroxide. What ends in OH? You know what? A base produces hydroxide ions in water. OH was the hydroxide molecule, the polyatomic ion. And compounds containing carbon. Most compounds containing carbon. L. Short answer. So, reading our periodic table. Again, they're not going to give you a chart, so you could kind of imagine them somehow, Sinead, writing these as multiple choice questions, okay? What's the symbol for scandium-49? Yeah. Can't remember. 18, non-metal. This was obscure. Non-metal oxide. I didn't really test you guys on that. I thought it was too nitpicky. Oh, well. Scandium-49. What's the symbol for scandium? Sorry? Capital S, lowercase c? What's its atomic mass number? Nope. On the periodic table it is, but look which element they gave me. They gave me an isotope. What, Courtney? 49. How many protons does scandium have? That's not going to change. That's from your periodic table. It's also called the atomic number. How many protons does scandium have? 21? How many neutrons? Normally, you would go 45, take away 21. This is an isotope. I'm not going to go 45, take away 21. What am I going to do? 49, take away 21. Oh, going to make sure you bring a calculator into your science test, yes? And now you can bring your good, fancy scientific math one if you want, and also bring it to your math exam, which is, I think, Tuesday. 49, take away 21. 28 neutrons? It's got a few extras. All right. What's 6027CO? What? Sorry? I got to be fussy. Technically, no, because they've given me an isotope. Not just cobalt, but cobalt dash what? Right? Cobalt 60. Cobalt 60. Mass number, 27. Number of proton. Oh, no. Mass number is not 27. What's the mass number? 60. Number of protons and atomic number, 27. Number of neutrons, whatever 60 take away 27 is. Last I checked, 33. Okay. Ooh. Last column here. What's the mass number if I have 7 protons and 8 neutrons? 15. What element is this? It's not element number 15. What element number is this? What element number is this? 7. Number of protons, which is what, Duncan? So we would write this as N, and since we're in our radioactive section, we would say a little 15 up there and a little 7 down there, and we would call this nitrogen 15. Complete the chart. Okay, now we're talking ions, 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 and ions. Okay. An oxide ion. Symbol O with a little 2 negative. How many protons? 8. That doesn't change. Oxygen has 8 protons. How many electrons? Normally, yep. I'm going to talk about that in a second, in about 10 seconds. So normally for an atom on the periodic table, oxygen has 8 protons and 8 electrons because oxygen is neutral normally. What's the definition of an ion? It's gained or lost electrons. It's no longer neutral. Now, look at where oxygen is on the periodic table. What's it going to do to fill its valence shell? So you find oxygen on your periodic table, what's the easiest way it can fill its valence shell? I think it can either lose 6 electrons or gain 2. What's it going to do? Oh yeah, that's why there's a 2 negative there. It's gained 2. So normally, if it was an atom, that would be right. Is it an atom, Matt? And its net charge is 2 negative or negative 2. It's gained 2 electrons, but electrons are negative. So it's gained 2 negatives. I've done my rant about how Benjamin Franklin named the charges wrong, and electrons would be much nicer if they were positive because we wouldn't have to say gaining is negative, but it is. Iodide ion, symbol I. Oh, let's change colors, Mr. Dueck. Symbol I. What's the charge on an iodide ion right from your periodic table? Negative? How many protons does iodide have? 5-3? How many electrons? Normally, Julia, it would have that many, but it's an ion. And it looks like it gained 1. 54. By the way, what family does iodide belong to? More specific, if you look at the column family, because along with chlorine and fluorine and the halogens, right? Very reactive. In fact, I think I told you chlorine is the only element that we can't store in glass. It actually eats away glass containers. We have to store it in special polysaccharides, along these long plastic things. Anyways, it's pretty nasty. Scandium. Ion. Okay, I recall scandium was SC. What's scandium's ion charge? Sorry? 3 plus? How many protons? What's scandium's atomic number? Sorry? 21? How many electrons? Normally 21, but it's become 3 more positive, which means it's lost 3 electrons. Its net charge is 3 plus. Let's do some naming. Yep. Quick like a bunny. So on the provincial, they'll make these multiple choice. In other words, if they said lithium iodide, complete the formula, I'll tell you what they'll have right now. They'll probably have LiI, Li2I, Lii2, and I don't know, Li2, something like that. Okay, making it multiple choice. So we're filling in a chart. Fair enough. Lithium iodide, the first thing I always do is this, ionic or covalent. Lithium iodide, ionic or covalent? Metal, non-metal, it's ionic. I'm going to put a great big I right here. Before I do the formula, carbon dioxide, ionic or covalent? This is covalent. Strontium hydroxide, strontium is a metal, this is ionic. Why is that so important? Because when we start naming stuff down here, we're going to have different rules for which ones. Lithium, this was where we used the crisscross rule. Somewhere off in the margin, we wrote lithium. We wrote its charge. I think it's a plus. Yes, I think lithium, it's element number 3, I think. Iodide, its charge is a minus. Hey, this is a perfect crisscross. This actually would be a nice, stable compound. It would end up being Li1, Whoa, do I write the ones? No. It'd be Li, Lii. In fact, really, I shouldn't leave a big space there. I should put it closer. So, okay. Carbon dioxide, is there anybody that hasn't memorized? What's the formula for carbon dioxide? You know what? Now, How would I derive that if I'd forgotten? I would say to myself, carbon has a charge of 4. Mr. Dueck, it's blank. That's because carbon can be 4 positive or 4 negative. It's right in the middle, so you have to count either from the left or from the right. But you'll notice carbon actually on your periodic table, they didn't put an ion charge, did they? I don't think they did. It's going to be 4 plus or minus. Oxygen has a charge of 2. When I crisscross, I get a 2 there and a 4 there, except it isn't just crisscross, it's crisscross and strontium hydroxide. I'll do that one on the right here. Strontium, Sr. Hydroxide, that's this one, or it's OH, I think, on your sheet, isn't it? Let's get it in the right order. What's the charge on Sr? 2 plus? From your polyatomic ions, what's the charge on OH? Negative? So when I crisscross, I get a little 1 there. I'll get a 2 there. So it's going to end up being SrOH2. Why is that wrong? What's wrong with this? I have to show that it's 2 OHs, not just 2 H's. I guarantee if this is on the provincial, one of the options would be missing the bracket. Okay? Ah! No. Here we go. Wait for it. Got your adrenaline rush now. You've missed that, haven't you? It's been a year. Complete the chart. So now we're going to names again. Key idea. We're nearly done. Is this it? Oh, even more. Excellent. Key idea here, I have to start out by asking myself, is this ionic or covalent? So, metal and nonmetal, ionic. Metal and nonmetal, ionic. Covalent, yeah. Can you wait till Max gets back, please? What's the name? Then, if it's ionic, the next thing I ask is multivalent or not. Can you find potassium? Is potassium multivalent? Nope. Then this is going to be potassium sulfide. Nothing fancy. The "ide" rule. You rewrite the first element, Matt, and then you add "ide" to the second element. Okay? What about copper? Cu. I'll see you later. I'll copper you later. Cu. Is it multivalent? Yeah. It's going to be Roman numerals. In fact, I'm going to have to figure out which one it is. So for me to get a CuBr2, let's see. What are my options? What charge can copper be? So I know that bromide has a charge of 1. For the crisscross thing to work, what charge must have been there if I ended up with CuBr2? 2, right? That's what would have given me this. So this is going to be copper. It has to be copper 2 bromide. SO3, covalent. It's still the "ide" rule, but now we don't need to worry about covalent. How many? This is the di, tri, tetra, whatever they all are, and you have those also on your provincial exam sheet on the same page as the polyatomic ions. This is going to be change colors, Mr. Dueck. Sulfur. No, sulfur? Yeah, S is sulfur, not silicon. Sulfur trioxide. 3 oxygens, 1 sulfur. Okay? It says, consider the following 2 drawings of a propane molecule. Okay. The darker spheres represent carbon atoms. The lighter spheres represent hydrogen. What's the chemical formula? Okay, how many carbons in this molecule? How many, Ty? No, it's on. Look up at the picture. How many carbons in this molecule? I caught you zoning out. My bad. You got to be with me. How many carbons here? 3. C3. How many H's? There's the chemical formula for propane. C3H8. Okay? Propane organic or inorganic? Organic. Write a balanced chemical reaction. Now let's start balancing equations, showing the combustion of propane. So I know it looks like this. C3H8, I'll leave a space, plus O2, I'll leave a space, and I know what the products are. CO2, leave a space. There's the skeleton equation. When you burn something, you get carbon dioxide and water. Now we balance. So here was what I taught you. I said we make a list. How many carbons are on the left right now? 3. How many are on the right now? 1. How many H's are on the left right now? 8. How many H's are on the right now? 2. How many O's are on the left right now? Careful, how many O's are on the right now? 3. Okay. And do you remember, what did I say we always leave for last because we're hoping it takes care of itself? Oxygen last. That's why I did it in that order. And a hydrogen second last. I'm going to start with carbon. How many carbons on the left? How many carbons on the right? How can I fix that? Put a 3 right here. That gives me 3. Oh, but that also changed how many oxygens, because now I have 6 plus 1. 7. I'll come back to that. How many hydrogens on the left? 8. How many hydrogens on the right? 2. How can I fix that and make it 8? Put a 4 right here. That gives me 8. Oh, but that also changed the oxygens. I got 6 and 4. Now I have 10. How many oxygens on the right? 10. How many oxygens on the left? 2. How can I fix that? Balanced. Hey, yeah, you guys got good at this. Beginning of the year, this was very difficult. You have been, out of my Science 10 classes, the best at getting the hang of balancing equations. I got to say that. Speaking of balancing, here we go. Let's classify first. So it says classify as synthesis, decomposition, single replacement, double replacement, or neutralization. What do you think this one up here is? A. Why? There's my acid. There's my base. There's my salt plus water. Let's classify the next one. What do you think B is? Single replacement, right? The zinc is bumping out the gold. We'll balance them next, but let's just classify them right now. What's this one here? It's when you combine two things with... Okay, C. Mr. Dueck can't say this. I'll spell. Oh, I missed an N. Synthesis. Synthesis. That one. Now let's balance. You know what? We listed everything last time. Let's see if we can go a little bit quicker and kind of just follow this through. Let's start. What would we start with here? I'd start with the nickels. I'm going to save the O's and H. H's for second last, O's for very last. How many nickels here? 1. How many nickels here? 1. Okay. Then let's do the Cl's. How many chlorines here? 1. How many here? Well, I can fix that by putting a 2 there. Right, Allison? Let's do the H's. How many H's just in this element, this molecule right here? 2. How many H's right here? 2, for a total of? How many H's on the left, Cam? How many do I need on the right? How many H's on the left? How many do I need on the right? How many do I have on the right? How many? 2. So I think I can put a 2 there, and that gives me 4. Right? Oh, please, it would be great if everything took care of itself. Now let's count the O's. Cam, how many oxygens here? 2. How many here? Trick question. How many here? How many here? Ah, it's balanced. There it is. 2 and 2 there. We're good. B. B. Okay. Well, let's start balancing. How many A, U? How many A, U are here? Quickly, bunny. How many golds? How many golds? Cool. I think I know what's going on. I think you know what's going on. How many? How many? 1 and 1. Hey, is this you know what? Ugh. How many CNs? How many CNs? Okay, what do a 2 and 3 have in common? We did this a bunch. What do we turn them into? Okay, so I can put a 2 here and a 3 here, but now that changed everything else. How many golds now do I have over here? Dylan, what? I need to put a 2 there. And how many zincs? I need to put a 3 there. You're saying 23, 23? Yeah. So you can do these, Courtney, without listing every single thing. Like, in other words, if you find you're running out of time, either on Wednesday or on the provincial, you can kind of start power balancing if you need to, right? Last one. I need 2 O's on the right because I have 2 O's on the left. Oh, I think just that. Nearly there. Sodium reacts with gas to produce sodium oxide, so with oxygen gas. What kind of chemical reaction is this? Sodium plus oxygen gives sodium oxide. Synthesis. Write a balanced chemical equation. Okay. Sodium. Can I tell you guys a joke about sodium? Nah. Okay. Plus oxygen. Why is that wrong? Okay. Gives. Now I need to crisscross to see what the correct formula for sodium oxide would be. The charge on sodium is 1 plus. The charge on oxygen is 2 negative. When I crisscross, oh, it would be Na2O. Are we balanced? Okay, let's balance. How many sodiums do I have here? How many do I have here? So first thing I might start doing is that. How many oxygens do I have here? How many do I have here? Oh! What did that just change? How many sodiums? 4 Na plus O2 gives 2 Na2O. Says, yep. Sure. Explain how the law of conservation of mass is illustrated by this reaction. Sorry? Atoms don't vanish. Okay. In other words, if something's missing, then you didn't have a closed flask. Something must have bubbled off into the air or something. See, there are chemical reactions where if you weigh them before and you weigh them after, the mass changed. And so people actually thought atoms were literally being destroyed or created. No. You know what? They bubbled off into the air and you missed capturing that or measuring that. So law of conservation of mass basically says in a chemical reaction, the number of atoms on the left of each type has to equal the number of atoms on the right of each type. In a nuclear reaction, the number of protons has to be the number of protons. The mass has to be the mass. Does that make sense? Okay. Oh, sorry. And that's the fancy term for that is if you have the same amount before and after, we say it's been conserved. So that's what the law of conservation of mass says. The amount of atoms before have to equal the amount of atoms after. Zinc metal reacts with hydrochloric acid. Predict the two products. I can't remember if did we drop zinc into acid and watch it bubble? I think we did. And the bubble was hydrogen. So you actually end up with zinc chloride and hydrogen, except I think that I've balanced zinc chloride wrong. What's the charge on zinc? Is it 2 or 3? What, 2? And chloride has a charge of 1. I think it's zinc Cl2. Okay, how could you increase the rate of this reaction? 2 ways. Give you 1, because that would cause the acid molecules to be moving back and forth faster. They're more likely to bang into the zinc and combine. What else? Yeah. I think so. What else? So there was surface area. There was temperature. Oh. And the last thing was add, and I don't know if there is a catalyst that will speed up that particular chemical reaction. There might be. Catalysts, most of those are inside you guys. A lot of the chemical reactions, like to break down food and things inside you guys, only occur because of the presence of catalysts. We're nearly there, folks. You guys have been great. Some radiation. Complete each equation by writing the correct nuclear symbol in the blank. What does this little star mean? This was gamma radiation and energy. So it's going to be the same 60 mass, the same 28, the same nickel, but it's given off a gamma particle. Which is the most dangerous form of radiation? Which goes through the most stuff? Alpha, beta, or gamma? Gamma. The Hulk is right, except you won't turn into the Hulk. Which one can't penetrate clothing or skin? Alpha, they're very big. They can't go through your skin or your clothing. If you swallowed it, it was something that gave off alpha radiation. That would be bad, though. Which ones can go through a couple layers of skin and clothing? Beta, because those are electrons. Again, 238, 4. This is going to be 234 as a mass, because it's got to add up. It's going to be 90. And what is element 90? Thorium again, which was TH. Capital T, Mr. Dueck. Here's an isotope of sodium. It gives off a beta particle. Got to be careful with the -1. If I have 11 here and a -1 here, this here must be a 12 so that it still adds to -1 along the bottom row. We've gained a proton. The mass is still 24, but now instead of sodium, we have element number 12, which is magnesium. Here's some half-life stuff. Yo. I skipped a question? No, I explained it to you verbally how the law of conservation of mass was illustrated. I went on a big rant about that. I didn't write it down. I figured you guys were. Okay. So once you balance it, what we're saying is everything gets used up on the left side and the right side. Is that okay? Argon, how some of you are right now. Gone. Oh, okay. It's a gas driven out of blah, 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 blah. Here's the day. Okay. How could I determine the age of a rock sample? Yeah. Forget that. That is a real quick review of the key points of chemistry. Okay? Physics, I'm just not going to get to. You guys are dying. It's getting hot. So first of all, let me hit pause.